In recent weeks, headlines have emerged that have captured our imagination and piqued our curiosity. The James Webb Space Telescope, JWST, is said to have identified what appears to be a bright carpet of artificially generated city lights on Proxima b. This tantalizing claim suggests that we may not be alone in the universe, a question that has captivated humanity for centuries. But what is the true background of this groundbreaking assertion? Are we on the brink of making contact with extraterrestrial neighbors, or should we approach these sensational reports with a healthy dose of skepticism? When we think of extraterrestrials, images of highly intelligent beings with futuristic technologies often come to mind. However, experts in the field take a different perspective. The search for extraterrestrial life is not solely focused on advanced civilizations, it also includes the pursuit of simpler forms of life, such as bacteria, microorganisms, algae, and plants. After all, Earth is currently the only known celestial body that has nurtured both intelligent beings and simple life forms. Yet, we still grapple with profound mysteries surrounding the origins of life on our own planet and the remarkable journey that led to the evolution of intelligent species capable of creating technological wonders like the James Webb Space Telescope. Despite our technological advancements, defining what constitutes intelligent life remains elusive. We have no clear idea whether extraterrestrial life resembles anything we know, and in the absence of comparable discoveries, we often find ourselves relying on our own existence as the primary reference point in the search for our unknown neighbors. Therefore, the quest for extraterrestrial life invariably hinges on understanding the conditions necessary for life to flourish, conditions that may be strikingly different from those found on Earth. Throughout history, humanity has been at odds with the darkness of night. We have fought against it first with fire, then with electric light. Our modern cities shine so brightly that their glow can be seen from space, obscuring the once awe-inspiring starry night sky. This raises an intriguing question: if other civilizations in the cosmos have followed a similar trajectory, could there be planets out there that glow just as brightly? And, crucially, would we even be able to recognize these artificial lights? Fortunately, we are not alone in pondering these questions. The topic of detecting extraterrestrial techno-signatures has been the subject of academic inquiry for years. In a notable study, researchers Eliza Tabor from Stanford University and Harvard professor Avi Loeb explored the feasibility of detecting city lights on Proxima b, a planet that lies a mere 4.2 light-years away from us, practically in our cosmic backyard. However, it's essential to clarify that the study's conclusions were theoretical. They sought to understand whether JWST could make such a discovery rather than claiming it had done so. The sobering reality is that even the most powerful telescopes currently available cannot directly capture the hypothetical city lights of Proxima b. However, researchers have devised methods to infer their existence. By measuring how much light the exoplanet reflects from its host star, Proxima Centauri, scientists can compare the expected values with actual measurements. If actual light levels exceed theoretical predictions, it may suggest the presence of artificial lighting. To understand the implications of the search for city lights on Proxima b, we must first delve into the capabilities of the James Webb Space Telescope. Launched on December 25, 2021, JWST represents a significant advancement in our ability to observe the cosmos. It is up to 100 times more sensitive to infrared light than its predecessor, the Hubble Space Telescope, and can capture astonishingly detailed images of distant celestial objects. For instance, JWST can even detect the faint heat emitted by a bumblebee on the surface of the Moon from Earth. Since its launch, JWST has been delivering spectacular images and findings that have reshaped our understanding of the universe. From the discovery of unexpectedly massive galaxies dating back to just a few 100 million years after the Big Bang to the confirmation of the Hubble tension, which reveals that the universe is expanding faster than previously thought, JWST has proven its worth as a powerful tool for astronomical research. Yet, despite its remarkable capabilities, JWST has not yet detected any signs of artificial city lights on Proxima b. When Tabor and Loeb published their study on May 17, 2021, JWST had not yet been launched. Their research was based on the hypothetical capabilities of the telescope, rather than any actual findings. The idea that JWST has detected city lights is, to put it mildly, an overinterpretation of the study's conclusions. In truth, the researchers focused on whether JWST could theoretically detect such signals in the future, not whether it had done so already. As we navigate this exciting yet uncertain terrain, we must grapple with the fundamental question: what makes a planet capable of supporting life? Proxima b orbits its parent star, Proxima Centauri, in the habitable zone, where conditions might allow for the presence of liquid water. This zone is crucial, as water is often considered a vital ingredient for life as we know it. However, the existence of water alone does not guarantee habitability. Other factors, such as atmospheric conditions and radiation levels, play a significant role in determining whether life can thrive. One of the fascinating aspects of Proxima b is its unique orbital characteristics. It orbits its star at a distance of just 7 million kilometers, completing a full orbit in just over 11 Earth days. This proximity means that Proxima b is exposed to significant amounts of radiation from its host star, which is a red dwarf with only about 12% of the mass of the Sun. This radiation can be both a blessing and a curse, as it can potentially provide the energy necessary for life but may also create hostile conditions that could inhibit its development. Returning to the search for artificial lighting on Proxima b, we face several challenges. For JWST to detect such lights, they would need to be exceptionally bright. If the inhabitants of Proxima b were to utilize the same type of LEDs as we do on Earth, the nighttime lighting would need to be approximately 500 times more intense for JWST to have a chance of detecting it. Alternatively, if the lighting intensity were comparable to that on Earth, the extraterrestrial lighting would have to be concentrated within a much narrower frequency range to be detected. Assuming these very specific conditions are met, it may be possible for JWST to glimpse extraterrestrial city lights. However, there are many caveats. We must remember that our understanding of life is based on our own experiences and the evolution of life on Earth. Just because evolution here has led to the development of eyes capable of perceiving visible light does not mean the same holds true for potential life forms on Proxima b. As exciting as the prospect of discovering extraterrestrial city lights is, it is essential to approach this topic with skepticism. In the scientific community, skepticism is a valuable tool. It encourages rigorous questioning and helps prevent the spread of misinformation. While the idea of detecting artificial lights on Proxima b is captivating, we must remain grounded in reality and recognize that we are still in the early stages of our exploration of the universe. As we look ahead, we must remain open to the possibility that the search for extraterrestrial life may yield unexpected results. With advancements in technology and new missions on the horizon, our understanding of the cosmos is continually evolving. Future telescopes may offer enhanced capabilities, enabling us to peer deeper into the universe and potentially identify signs of life. Moreover, the search for extraterrestrial life is not limited to visual detection. Scientists are exploring various methods to detect biosignatures, chemical indicators of life, in the atmospheres of exoplanets. This approach expands our search beyond the confines of city lights and opens the door to the possibility of discovering microbial life or other forms of existence. The search for extraterrestrial life is an ongoing journey, one that requires patience, curiosity, and a commitment to scientific inquiry. As we continue to explore the universe and push the boundaries of our knowledge, we may yet uncover the secrets of life